So now we're going to take it up another level and start talking about object-oriented programming, right? So this is, let's say, conceptually a fairly universal topic that can be applied to any object-oriented language. We're going to focus, of course, on the Python implementation thereof, but the same ideas are fairly universal. Okay. So I think given, let's say, the responses to exercises and so far, I think we can take it slow and just take it step by step and see how far we go. But please do ask questions and don't be shy. Okay, so we talked a lot about dictionaries this morning, and I told you that dictionaries were fundamental to how Python works, right? So now I'm going to prove it to you, and I'm going to prove it to you by explaining how classes work, okay? In Python specifically. So before that, let me just show you what we'll cover in this session. So we're going to start with just kind of introducing what object-oriented programming means in general. We're going to have a simple example in Python just to show what it means like altogether in a very basic application. Then we're going to take a big step back and we're going to really like dig deep inside what a class is and how it works in Python. So we're going to get into some pretty high-level details. You don't need to understand every single thing, but I'm going to really pull back the curtain and show you all of the inner mechanics of what is happening inside a Python class. And then I'm going to close the curtain and show you how you should use it. Right? Now, the point is, at the end, all you need to know is that last part of how to use it. But once you know how it works really behind the curtain, then you will have no problem writing your own classes and understanding other people's classes, right? So there will be complete demystification of how classes work. Right, so then I'm going to start talking about some very specific points in Python classes, in particular methods. Then we'll move on to class properties and operator overloading, right? So this will be the first session. If we have time, and depending on how things are going, I have a second notebook, which is even more advanced, where we start talking about inheritance, composition, and abstraction of class methods, which is like really pushing it, I say, towards the high intermediate to advanced levels of Python. But we'll start at the beginning and see how it goes, okay? So again, don't hesitate to interrupt. Okay, as with the previous notebook, make sure you run the setup cell before moving on. We need pi and square root functions from math package and the usual clean printing error function. So make sure to execute that before moving on. Okay, so now we can start talking about object-oriented programming. Okay, so there are many different object-oriented programming languages out there. For example, C++ is fully object-oriented. Python is extremely object-oriented because I told you this morning, everything in Python is an object. So therefore, everything that Python does is object-oriented. But like to really be, thinking in an object-oriented way, you should start thinking about how you handle objects and how you create objects and what an object actually is. Okay, so the reasons for using or let's say thinking about your code in an object-oriented way is you can take advantage of topics like abstraction, encapsulation, inheritance, and polymorphism. Right, so these are all like fancy computer science terms that we can kind of break down to simpler things, and we'll kind of see when we deal with each of these sort of topics what I mean by that. But essentially, by abstraction, we kind of just mean that we only if as a developer we only want to show certain things to the user, right? So basically, you can imagine if you were selling a car or a computer or something, you don't want to show all the gears and wires and all that sort of stuff. You want to show the whole kind of thing that the user is actually going to use, the steering wheel, the seats, and so on, the parts that they're going to interact with. Everything else can be under the hood and hidden as long as it works. They're free to open up and look inside, but they don't have to in order to use it, right? And that's kind of what we mean by abstraction. So we write the code. We want the user to be able to use a function or a class or something. We make sure we show the user the bits that they need to see, and we can kind of hide other bits that they're free to investigate on their own time, but they don't need to look at in order to be able to use those tools. Encapsulation, right? What we mean is like, well, you know, there are a lot of features that kind of go together. Like if we have certain calculations that are related to other certain calculations, rather than having them as separate functions and separate files on separate computers, we can encapsulate those into a more structured object. So we say, okay, all of these functions and all of these things are, you know, really related to the same idea. Maybe we can stick that all together and encapsulate all that information in a cleaner way. So then inheritance, we'll only talk about if we make it to the next notebook, which is really like basically maximizing the reusability of your code, right? So we talked about earlier that, you know, I don't like, you know, equations written into for statements because it's completely unreusable. So, you know, write a function. Well, we can go even beyond that. We can say, well, if you write a class, some of the components of that class can be reused if you allow for inheritance into other classes. So we'll get into what we mean by that. And polymorphism kind of means different things depending on which language you're talking about. In a Python sense, it's really just basically allowing certain objects to take multiple forms. So, you know, essentially allowing, you know, methods that have different arguments that can be placed into the method rather than just a single argument. Okay, so why do you want to, sorry, I think I skipped ahead a bit. So why do you want to use, let's say, those object-oriented ideas? What benefits will they bring? So one of the most important ones, of course, is reusability, right? So writing any code, being able to reuse most of that code possible really maximizes the efforts that you've spent, right? So if you write a huge long code that you can only use once, it's really a waste of time, right? You want to be able to use as much of your code as often as possible in order to really make, you know, take advantage of the time you spent developing. So another important aspect is maintainability, right? So you've written a code and you're happy with your code, but eventually, you know, libraries, dependencies, and all these sort of things change, bugs are found and all these sort of stuff. So the easier it is to maintain your code, the more likely you will maintain your code, right? So if you've written a really messy, scrappy code, it's gonna be very hard to keep it up to date, keep it clean and find bugs. If you structure everything nicely, it's gonna be a lot easier to fix things, find problems, and resolve them. And then, yeah, so security. So basically, if you write your code well enough, you make it very hard for the user to break, right? So if you write a bad function, you have a high probability that the user will produce bad outputs. If you write a better function, you reduce that probability. If you write an excellent function, you make it almost impossible for them to misuse your function, right? So you say, okay, I've written so many exceptions into my function that you can't do the wrong thing without getting an error or a proper message telling you what you've done wrong, right? So, you know, thinking about those sort of things is really what we want when we think about object-oriented programming. So again, this is completely universal, but we're going to now focus on what this means for Python. Okay, so as a just simple kind of example to ease you into the topic and, you know, take it nice and slow, let's look at a specific example. Okay, so this, you know, this will seem familiar from what we were talking about with dictionaries earlier this morning. So, okay, imagine we're working on a project and you have to keep track of various properties relating to planets in the solar system. Okay, so you want to know, let's say in this particular case, you want to know the radius, the mass, the gravitational acceleration at the surface, and you want to kind of keep track of all of that information, right? So similar to what we discussed this morning, one thing you could do is, okay, you could define individual parameters, objects for each one of these values, right? So we could say, okay, we create a variable called the Earth's radius where we store that value. We create another variable, Earth's mass, and so on and so forth, right? So in which case then we have all of that information that we can keep inside of our code. But of course, that's extremely messy because if we have to do this for all of the planets in the solar system, we're going to end up with a lot of variables that we have to manage, and it starts to get pretty messy. Yeah, in particular, you know, 21 more. Okay, so then again, what we talked about this morning is, okay, well, one way to store information in a single object is by using an array-like object, like a list or a tuple in Python. So, okay, so instead for the Earth, rather than having 3 different parameters, we could have, variables, we could have one single object with 3 values. And we get all the same information in a much more encapsulated way. But again, we have to remember what those parameters are and the order that they're stored in that list. Okay, so if we knew that, then we're fine. But the more information that we want to stick in there, the less likely we're going to remember what the fourth parameter was for this particular object. So this morning, and now you're all experts on dictionaries, like, okay, well, there's no problem. I could just make a dictionary, right? So I could create a single object, and I could store all of the parameters with named keys so that I can keep track of everything extremely easily. So I have all of this nice information stored in a nice single object that's very easy to use. But this isn't the end of the story, right? Because this is fine, but imagine I have to do this for all the planets. It means I have to write, 7 more dictionaries that store the same information, which is, not that difficult for, this number of objects. But again, let's say we're doing this for some Euclid data, and you're like, okay, I have 10 million objects, and I want to create a dictionary for all of them. You're like, oh man, this is starting to become a pain, right? So what can we do? Well, we can start to think about how to make this a bit more generalizable, this particular problem. So let's take it from one step beyond the dictionary and go straight to building a class. Okay, so yeah, so one important note here is that, like, for this first example, I'm just going to show you kind of a whole class all put together, and then we're going to go back and take all the pieces apart one by one and go through what all that means. So don't worry too much about the syntax for this first example. Just think about what it's doing, and then later we're going to go through what every single word in that example means. So don't worry about that for the moment. Okay, so here's our first example. We have a class, we're calling it planet. Okay, so I'll explain what all of these things do in a bit, but for a moment, let's just execute this cell. So we have our class defined, and now what we can do are create objects. So this is where we're really coming to the concept of object-oriented, right? So our class is our object generator, if you want to think about it in this way, right? So what we're doing is we're going to call our class, which is just called planet. So it's a generic thing. We're going to specify the parameters to our class. And then we have a special show function, which I'll just show you, shows here, basically prints all that information we had previously. Okay. And now you can see it becomes extremely easy to encapsulate all the same information that we had for all of the planets. All we need to do is basically create instances of this same class for each of those objects, right? So now we can create independent objects for each planet with the same class, right? We don't have to redefine a new dictionary every time. We don't have to redefine the same structure every time. We have uniform structure for all the objects very simply. Is that clear so far? Okay, so this is really kind of the core, let's say, conceptual thing. What we're trying to achieve here is basically have the level of abstraction and like something that we can generalize to the extent that it makes it very reusable, right? Okay, so let's, okay, so, point one is that, of course, the class implementation is more complicated than just writing the dictionary. But we can save ourselves time in the long term, right? So the thing is, the little bit of extra effort we do at the beginning and thinking how to abstract this problem into a class saves us a lot of effort in generating the objects we need for each of the planets. And that's exactly the kind of thinking that you want, is essentially, okay, what can I do now that will make this easier later, right? Rather than doing the easiest thing now and then figuring out, oh, this is going to become harder and harder as I get more and more data. Okay, so now that we've seen kind of, right, conceptually what a class is, and we understand, okay, basically why this might be useful for, whatever work we happen to be doing, let's now figure out exactly what the class is in Python and how it works. Okay, so I've entitled this section Dissecting a Class, and I think it's a pretty appropriate description of what we're going to be doing, because we're really going to be taking a class and pulling it apart and looking at what goes on inside. Okay, so first thing we're going to do is, if you remember from how to define a function in Python, the syntax was def, the name of your function, colon, parentheses, colon, and then whatever functionality you have. It's very similar for a class, essentially just class, the name of your class, colon. Now this is, I should point out, Python 3 specific, right? So if you want to go to Python 2, well, which you shouldn't be doing at all at this stage, you know, there's a slightly different behavior. So just everything that we're talking about from now onwards is very much in mind that we're talking Python 3. Okay. Okay. So what is this class doing? Well, this class, I have a special null statement called pass, which basically means it's doing nothing. So this is literally the most basic dummy class you can define, right? So it's just the name of the class and it has no content and does nothing, right? So that might seem pointless, but I'm going to show you that there is still some information inside that object. And this is going to be the easiest way to start looking at it. So it's like taking the simplest organism you can find and cutting it up into pieces to see how it works. Okay, so let's start with, so there's a fancy function in Python called help, which is a pretty useful thing to know about if you weren't aware of. And you can write help and pretty much any object in Python, and it will give you docstring information for that object. So let's try it on our dummy class. So we saw that we didn't put anything into the class. So let's see what help tells us. Well, the help tells us that we're dealing with a class called myClass. Well, that's good. So we know what we're dealing with. The class is defined in main, which is essentially the current module that we're working in. And it has two things inside of it. One is an underscore underscore dict underscore underscore, and another one underscore underscore weak ref underscore underscore, right? So let me explain a little bit what's going on here. So weak reference is a kind of very specific and fancy thing that we're not going to get into today because it's a little bit too advanced. But it really has to do with like really core Python functionality and essentially keeping correct references to objects and so on. We're not going to get into that. It's far too complicated for the pointer today. But the other object, the dict, we are going to talk about. And the reason we're going to talk about that is because it's a dictionary, right? Now, and you guys learned everything about dictionaries this morning. So you're experts on dictionaries and no reason to be scared of a new dictionary. Okay, so basically the reason that there's a double underscore is because this is kind of doubly hidden object, right? So Python doesn't have like public and private variables the way you would get in certain other languages, again, like C++. But it does have a kind of convention, right? So that essentially, if you have an object dot something that's like public, let's say, underscore that object, it means it's hidden, and underscore underscore is really like, this is hidden for like core Python, okay? Now, so in principle, you should never have to interact with any of these underscore underscore things directly, right? This is really coming back to the idea of abstraction, right? So the reason that they put this in, the core Python developers have put these things in here is kind of hide this machinery in the way Python works, and you just use the class as the way you're supposed to. Today, like I said, we're going to peel back and look at what's going on inside. So let's have a look at what this dictionary's got inside of it. So first, we're going to print out the dictionary itself, right? So basically, we're going to call the class itself, the class object, and dot the dict. And then we're going to print the type of object. Okay, so in the type, we can see that this is a mapping proxy, which I'm going to just assume with a show of hands that nobody's heard of a mapping proxy before. No? Okay, good. I didn't think so. Right, so, right, sorry. And then the other thing is you can see that the dictionary is indeed a dictionary. We've got some curly brackets here. And there's several things stored in that dictionary. So again, we didn't put anything in the dictionary, but we can see that there's already some information in there. So one is the module. So it's saying, where is this class defined? So this class is defined in main, which I said, again, is the current module that we're working in. So the dict is a member of the dict, right? So this is a little bit of a complicated sort of inception level deal. We have this weak reference thing that we're not going to talk about. And then we have one called doc, which at the moment is set to none. Okay, so let's have a look. So doc is the class doc string. So we're going to have a look at some class doc strings a bit later. Since we didn't define a class doc string, it's set to none. So that makes sense. And like I said, the module is the name of the module. Okay, So what is a mapping proxy then? So mapping proxy is actually is just a dictionary, but it's a very specific type of dictionary. And it's a type of dictionary that doesn't have a very special method called set attribute. All right, and I'm going to explain what that means in just a second. Okay, firstly, maybe I can split this to make that a bit clearer. Okay, so first let's try something. So if you remember when we were talking about dictionaries, we had a couple of ways that we could add elements to a dictionary. And one of them was assignments. So in the case of a standard dictionary, what we would do is say dictionary name, square brackets, the name of the key that we want to add equals, and then the value that we want to include into the dictionary. All right, for a class property, it's the same sort of idea, but we're just using a dot. We don't need to use any square brackets or anything. So essentially it's the name of the class dot, the name of the parameter you want, and assignment to the value that should be assigned to it. Okay, so basically what I'm doing is taking my dummy class that has nothing, coming up with the name of a random attribute that I've just come up with, right? So this could be literally anything, and then setting a value. So I'm just choosing, in this case, a Boolean, which is equal to true. So now I'm going to print out the same class dictionary that we looked at before. And what you'll notice is that at the end of the dictionary, we've now got a new attribute added to this. So, do take a second to take this in. So what does this mean? It means that basically when I have a class and I do a dot assignment to a parameter, all I'm doing is interacting with this _ dict inside the class, which is just essentially like a normal dictionary, but it's this fancy mapping proxy. Okay, is that clear so far? Yes, okay, I got one yes. Is there any more nods? Okay. All right, so like I said, this is more information than you really need to know, but I'm gonna give it to you anyway. Okay, so if I wanted to interact with this class dictionary in the kind of standard dictionary way, I could say, okay, my class dot the dictionary and show me the lookup of this attribute in exactly the way I would with a normal dictionary, and it will work. You can see that we assigned this value, and we can even look it up in a typical kind of dictionary way. So the reason why this mapping proxy is special and different is because without this set attribute, we can't change the values of the dictionary using this approach, right? So if I try to do a new assignment to that variable using dict, it will raise an error. And it's because the set attribute doesn't work. So this is why you have to use this dot assignment thing for class properties, right? The thing is the dictionary is there. And when you're doing that dot assignment, you're interacting with that dictionary. But like I said, this is behind the curtain and it's not for you to see. So basically, it's good to know that all you're doing is really just manipulating a dictionary when you're manipulating a class. But you have to treat it like a class with that knowledge. Is that clear? Sort of? Okay, well, we'll get into a few more examples in a bit. Maybe it will. Okay. Yeah.
When you say attribute,
yes.
how do you define do you use it for the dictionary, but for the keys of the dictionary? So is there a specific definition for the word attribute?
Right, so attribute, well, so basically anything that belongs to a class is a class attribute.
It's the dictionary, but it's also my attribute. So the
yeah,
of the
yeah,
dictionary.
yeah. So basically,
we would call both of them like class attributes.
Yes. Yeah, because essentially, like you have properties, which are usually more like values, and then you have methods, which are like functions, but both of those are attributes. Okay, so here's another example. Okay, so now we're going to define a new dummy class. All right, so again, my class, but this time we're going to predefine inside our class some attributes. Okay, in this case, some properties. So, okay, we call my class. We're going to define a Boolean, an integer, a float, and a string. And then we're going to print this class dictionary again. So if you remember the first time we had some stuff in the class dictionary, but it wasn't anything particularly interesting, let's say. And now, when we do it, we can see one, that this, at the beginning, we have these three double quotes and some text in there. This is our class docstring. So now if we look at the doc inside the dictionary, we can see that it is included, that docstring, right? So now we can see that we can actually manipulate that docstring. And all of those variables are also included in that dictionary. So now you can start to see that basically just by defining these class things in a traditional sense and the user side, that behind the scenes, all that's happening is it's added some new information to this kind of hidden dictionary. Is that clear? Great. Okay. So now that I've defined this class with these attributes, I can access those attributes as well, right? So they're predefined in the class. So if I wanted my class to tell me what the value of my bool, int, float, etc. is, I can print those things and access them with no problem, right? And they can also be modified through these dot assignments. So basically in my class, I want to change the value of my string. So my class.myString, I changed the string value and print it, and now have a new string value. Right, so yeah, so this is a good point here. So all of this, what I've just shown you, is really just to explain that there's no magic going on with the way these classes work. All you're doing is having kind of a different interface for interacting with the dictionary. But at the end of the day, you shouldn't ever have to interact with this the dictionary yourself, right? It's good to know it's there. It's good to know how it works. But at no point when you're writing code or writing code for others to use specifically should they need to use this, right? It's just good to know it's there. And especially if you're dealing with a class that somebody else wrote and you don't really understand what's going on inside, maybe you can have a look at the dictionary for that class and might give you a bit of a hint of how they set it up and might give you a little bit of a clue as what they were aiming to do. But in principle, I would say if somebody wrote a class that you need to look at the dict for, they probably didn't write it very well. Okay, so that's the first point. So the second point, now we're going to move on to the topic of instantiation. Okay, so as this is all about object-oriented programming, we need to actually create some objects. So far, all we've done is actually interact with the class itself. But the class is only really useful for object-oriented programming is if we use it to create objects. So objects and instances are synonymous in this sense. So basically, when we create an instance of our class, we have created an object. Okay, so how do we do this? Okay, so basically, in the simplest sense, all we need to do is put some round brackets after the name of our class. Okay, so our dummy class, as we saw, just had a few dummy variables that we stuck in there. To create an instance of this class, we would just call the class name, put some curly brackets there, and assign it to an object. Okay, now we can look at the dictionary for the instance, right? So we're not looking at the dictionary for the class, we're looking at the dictionary for the instance of the class. All right, so notice that the instance dictionary is empty. And notice, more importantly, that the type of object is actually a dictionary. It's not a mapping proxy anymore, it's just an actual dictionary. So essentially, so this is important to keep in mind. So the dictionary for the class itself had some predefined variables and it's a mapping proxy. The dictionary for the instance is just an empty dictionary. Okay, so now, again, this will all start to make sense soon. Okay, it's still possible for the instance to see the class dictionary, right? So now this, again, something you'll never ever have to do in your life, but there's a hidden variable called class, which can access the hidden variable dict, which will give you all the way back to the class dictionary. So what all this really is to show is that you have, the instance has its own dictionary, but the instance can also see the class dictionary. So it basically has a whole hierarchical chain of dictionaries that it has access to. Okay, so and a very, very important thing to know is that instances are always unique. if I took the same class with the exact same values and created 2 instances of it, so we can see we had a dummy class that really just had some dummy variables set in it. I create 2 independent instances of this class, and then I'm just going to check if they're equal to each other. And the answer is no, right? So Python knows that when you create a new instance of a class, it is unique always, right? It doesn't matter if they have the exact same values for every parameter, all instances are always unique, right? So this is, again, really like the fundamental core of what object-oriented programming is. Each object is a unique object. Okay, so since we mentioned we can assign attributes to the class itself, we can also assign attributes to the instance, right? So we have my inst, which is an instance of my class. I'm going to create a new variable called new bool, set value of false. And then I'm going to look at the instance dictionary and the class dictionary. Okay, so now we can see that the instance dictionary is no longer empty. We have now a first entry into that dictionary, which is not included in the class dictionary, right? So basically by doing an assignment to the instance, I've updated the instance dictionary and not the class dictionary. Again, a really important distinction between instances and the classes, right? When you interact with an instance, you interact with the instance, not with the core class that produced the instance. Okay. Okay, so now, all right, that's all fine. That was a very dummy instance, but imagine we want to give our instance some parameter values from the beginning, right? We want to, when we create the instance, we want the instance to already have some predefined variables. So what we can do is we have a special init method, right? So this is one of the rare cases which a double underscore thing that you will have to use a lot, is basically the method that allows you to instantiate your class objects, okay? So it has a special argument called self that we're going to discuss later. So for the moment, don't worry about it too much. Self is going to dot assign a variable. So in this case, we're just going to call it my float and give it a value. And then as before, we're going to take this class, create an instance of it without any arguments, and print the instance dictionary and the value of that variable, right? So you can see that the dictionary includes my float, and we can access that value. So it's identical to what we did before, right? So basically, if we created the instance and then assigned the variable to the instance, it's this exact same thing as if we just predefined a variable for that instance inside the class definition, because in both cases, all we're doing is adding values to the instance dictionary. Is that clear? Yes, and I will explain that explicitly in just a second. So it's a good question. Okay, so at the moment, we're going to get into the syntax of self and where the things go. But for the moment, the main important point to take away is the difference between the class itself and the instance. And really, if you really want to pull back the curtain, the only difference is that there's a dictionary for the class, which is a mapping proxy, and a dictionary for the instance, which is just a normal dictionary. And depending on which thing you're interacting with one or both of those dictionaries. That's it. That is the fundamental thing of how classes work in Python. It's 2 different dictionaries. Okay, any questions on that? Great. Okay, so again, we'll come back to self a little bit, but the main thing is self, what it means in this context is the name of my instance, for example. So essentially, because my instance is an object that I create when I create the instance, the class doesn't know what the object is, right? So I can't say initialize this class with my inst.myFloat equals this, right? So I have a special method called self that says, okay, whatever the instance is that I'm instantiating, it's for now I just call it self, and then you give these values to that particular instance. Okay, so we'll come back to that in a bit. No, it's mandatory. Yeah, you have to write self. Okay, so basically, right. So they're just showing again that this pre-instantiated instance can also be manipulated, right? So I can change the value of my float, which I had instantiated inside the class. I can change outside the class, right? So basically, once the instance is created, I can change that variable. And of course, all it's doing is changing the value inside that dictionary. Okay. And then, yeah, okay, so now getting to more realistic case, of course, we don't necessarily just want to instantiate our class blindly. We probably want to pass some arguments to our class that give it certain properties to instantiate with, right? So essentially, to this init method, we can add additional arguments, as many as we like, and then pass those into instance variables. So for example, we could create this class. It takes this value and assigns it to my float, right? So if we take two different instances of the same class with different values, we can see that we get different values of my float. And again, all we've done is created two independent instances with two independent dictionaries and assigned two independent values to those. That's all we've done. Okay, and this is an important detail. Right, is that instance variables, attributes, will override class attributes with the same name. Okay, here's an example. So this is kind of coming back to your question just a second ago. Imagine if we created our class and defined before the initialization a variable. So here we have my float defined just after the class. Right, then we have an init method which does nothing, it's just passing. Okay, so what's going to happen? Firstly, I can create an instance, two instances of this class. So two independent instances of this class. And what we can see is that the class value of my float is 6.15. The instance value of my float is 6.15. Both instance dictionaries are empty. Okay, so you can see that basically both the class and all of its instances have access to the same variable, which is my float. But the instance dictionaries are empty. So all this is doing is basically the instance doesn't have an attribute called my float. So it says, okay, my dictionary doesn't have this attribute. I'm going to look at the class dictionary. The class dictionary does have this attribute, so I will access that value. All right, so look what happens if we change the first instance value of my float. So we leave the second instance alone. The first one, we're changing my float to 8.18. So what happens? The class value stays the same because the class dictionary doesn't get touched by the instance. First instance value has changed, as well as the first instance dictionary, right? So now the first instance has an attribute called my float, and the class it points to has an attribute called my float. So the instance says, okay, well, I am going to prioritize my dictionary over the base class dictionary. So that means that when I look for my float, I look in my dictionary first. If I find it, that is the value I use. If I don't, I point to the class dictionary. So essentially, you can see here, the second instance, my float has unchanged, and as well as its dictionary. And if we look now at the bottom, where we've looked at the first instance, pointing to its base class and its dictionary, we can see that my float is still 6.15, even for that first instance. And it's only because its own dictionary has the same variable that it overrides that when you do the call. So this is a little bit complicated, so don't hesitate to ask questions if that's not clear. Yeah?
The last line
Yeah.
where you show the name, class, and dictionary.
Yeah.
You could have also just written class, my class dot dictionary.
Of course.
You need to
No, no.
instance one
No,
and then
no, not at all. This is just to kind of ram home the point that this is the same class that instance is pointing to, and they both have my float and they're different values. And the thing is that when I call my instance my float, it's looking here, whereas this one, when I call my float, it's looking here. Okay, so this is just again important to understand the distinction between instances and the classes, and also to understand the hierarchy of what it prioritizes, right? So instance dictionary goes above the class dictionary, and only get to the class dictionary if you don't find what you're looking for in the instance dictionary. Okay? All right. So we're going to move on unless there are any questions. So again, the whole point from this section is really just to understand the two differences between those two things. And hopefully I've revealed to you that it's really, there's no magic going on. It's really just a matter of separate dictionaries and the hierarchy of which you look up those dictionaries. About as simple as you can make it. Yes? Yeah.
Usually I start with you with
Yeah, so it depends on what you want to do. So basically, by default, you don't have to explicitly specify the type of anything in Python. And that's one of the benefits of Python, is that you actually have the flexibility of type and mutability of type. The thing is that if you want to really make fast, optimized code, having explicit types can make the implementation quicker. And that's because essentially it works more, because all of Python is written basically in C. And so essentially you're like interacting with the C almost more directly that way. And so it just makes it a bit faster. So it depends on what you want, right? So if you want something that is more user-friendly and flexible, then you probably don't want to explicitly set the types. If you want something that, let's say, is just doing some like hardcore processing and grinding out results, then you might be beneficial. It really kind of depends on the application. Yeah. Yeah, sure. And if you know that, that's fine. But the thing is that, and sometimes it can be beneficial to say, let's say I have a variable called X. And like in some cases, I want to pass an integer, which does something, but maybe I pass a string instead of an integer and it does something completely different in behavior-wise, right? And having that flexibility is really useful, because then you don't have to add a third variable to get the extra functionality. It can be the same variable, right? In which case that mutability between type is really useful. But like I said, if it's just like core grinding out results and you know it's always going to be a float coming in and always a float coming out, then you can explicitly make that hard-coded. Okay, right. So now that you understand what the class is, you understand the difference between an instance and the core class itself, we can start talking about class methods. Okay, so important thing. So this is a kind of just a syntax linguistic thing for Python. Method is just another word for function, but there are specifically functions that are inside of a class. Right, so this is just a useful thing to know. If you go talk to some computer scientist or you go to a Python conference and they're talking about functions and methods and you're getting a bit confused, really what they mean is a function is defined inside a module, a method is defined inside of a class. That's it. Okay, so just clear that up now so that we don't have any confusion later on. Okay, so back to like point number one from the whole objective of today is that everything in Python is an object. Everything. Okay, so let's define a new dummy class. Again, the same boring dummy class that does nothing. And we're going to define a function, a very simple function that just prints hello. Okay, this function is an object. Any object can be assigned to an attribute. So if I say my class, my function, I can assign this function as an attribute to my class. And then this class can then call that function. Right? So you can see here, my class.myfunc says hello. And if I look inside the dictionary of my class, you can see that I have myfunc as a key and the corresponding value is a function called say hello. So essentially just, again, this is just to point out the object nature of Python is that even a simple thing like a function can be assigned as an attribute to anything. And in particular, as a class attribute. Okay, so in principle, you're probably not going to want to do this specific thing because that's kind of redundant. Like, why would you need to assign a function that you've already defined to a class? You know, there might be a situation where that rises, but more likely you're probably going to want to define the functions for your class inside the class. So the simplest way to do this, now I'm going about this in a slightly backwards way. Normally you would approach this looking at instance methods, but we're going to do it the opposite way, just so we can kind of build up and you can understand exactly how all the pieces fit together. Okay, so we're going to define a class called calculator. Calculator has 4 attributes, which are methods: add, subtract, multiply, divide. Each one takes its own arguments, x and y. And if we look at the dictionary, we can see that we have all of those functions defined in the dictionary. Okay, so nothing special going on there. All right. Why would you want to do something like this? Well, we talked about the idea of encapsulation, right? If we have a bunch of functions like this that do similar sort of things, rather than having them randomly scattered all over the place, we could define a single class that encapsulates all that information into a more compact object. Okay, so of course, once we've defined those class methods, we can use them. So we call our calculator, we can call each of its methods and put in values, and it will work. Nothing particularly special going on there. But since we define those methods inside the class directly, like that, with just the, as if it was a normal function, these methods only exist inside the class. So one, we can't call add outside of the calculator, which makes sense. That's the whole point of the encapsulation. Otherwise, there would have been no point to the class whatsoever. The other thing is that those methods cannot be used in an instance. Now, this is more important, right? So if we make an instance of calculator, so create an object equal to calculator with this, and we call the instance.add, it will raise an error. Now, we're going to go into in a minute what this means, but basically what it's telling you is that the method add was looking for 2 arguments, but you provided 3. And now if you look here, you can see that 2 arguments were passed. But that's because when you define a function inside of a class and make it a method, Python automatically passes the instance name self to that method as an argument. So even if you don't give self, Python will pass self. So essentially, if you only provide 2 arguments to your function, Python is always passing 3. So we'll come back to this in a second because it might seem a bit confusing, but again, just to show you the class definition. You can see here, all we've defined was a normal function. If we copied and pasted this outside of the class, it would work exactly the same as a normal function. But clearly doesn't work for the instance, right? And the reason for that, like I said, is that it's expecting self to be passed, right? So how can we stop it from doing that? Well, we can add this decorator. So we don't have time to go into the details of decorators today. So I'll just let you know in a kind of 2-second explanation is basically anything with this at sign above a method like this is basically modifying the functionality of that function. Okay, so essentially all I'm doing is saying, okay, there's a function called and then I'm adding the attributes that self should not be passed to and, right? So that's all that's changed. So this is almost identical to the previous class, except that I've just made all of these methods static. And now if I look at the dictionary, you can see that basically instead of being defined as functions, that there's, if I could find one of them, that they're defined as static methods, right? So you can see already the object type has changed inside the dictionary. And now when we try to implement this, you can see it works. Now, basically, if I create an instance of calc and use the add function, it works. I can also call the class directly and you call the method and it still works, right? So basically, the point is that first example where I showed you a calculator with just functions defined in it is something you should never, ever do because there's absolutely no benefit to doing that whatsoever. Basically, all you've created is a kind of redundant class that can only be used in one way, right? Which is not very sensible. So if you wanted something like this, where you say, okay, I want to be able to call the methods directly from the class without creating an instance, you should make them static, right? By definition, because that means if you did choose to make an instance of that class, it would still work, right? Yeah. Sorry? Well, there are two things, right? So one here, I'm printing the class here, and here I'm printing the instance. So they're doing the same thing. So that's why we get the same output twice. But in fact, this one is calling the method from the class, and this one's calling from the class instance. So that was kind of the whole point here, is to show that it still works. Okay. So that is what a static method is, right? So basically, it's the most simple function you can have inside your class. It has variables that get passed to the function like any other function and gives you an output. And you can call it from the class or from an instance. Great. Now, that's not that useful, because essentially, what's the difference between defining a class with a bunch of static methods and rather than just creating a Python module with all the functions I want in it? I mean, there's not much to gain from that implementation. So the next thing we can do is we can step it up a little bit and start looking at class methods, right? So class methods are similar to static methods in the sense that we're going to define a decorator again. This time, instead of calling it a static method, we're going to call it a class method. And notice that we are passing an extra argument to our functions. So this time it's an argument called CLS, which is short for class. And what that does is it allows us to access class properties or class attributes. So essentially, the things that are inside that class dictionary that we looked at at the very beginning of this can now be accessed inside the class methods. So imagine I have a class for calculating the Stefan-Boltzmann law. Okay, I have a constant that I need to use for all of these methods, right? So I could calculate the luminosity of a star. So 4 pi r squared sigma T4. So I think any astronomers would be familiar with that equation. But maybe instead of calculating the luminosity, I want to calculate the radius or the temperature. So again, it's just different variations of the same equation, but they all use the same constant. So if I was defining these as 3 independent functions, I would either have to do redefine the constant in each one of the functions, or pass an extra argument, which was the variable sigma to each of the functions, right? So in both cases, I'm adding some mess and complexity to the implementation, whereas this is a genuine case of encapsulation, right? These things are completely related to each other, so there's no real reason to have these as completely independent functions. I can define the constant once and clearly inside the function, so that way, if I had the wrong constant here, I could fix it one place that fixes it everywhere in the code, right? So this is, again, for maintainability. So now I've made it easier to fix and maintain my code. And yeah, if I look at the dictionary, you can see that these objects are now class methods rather than static or just standard functions. So what does that do? Okay, so basically, you can see firstly that it works. So if I call the class dot the method and pass some variables, it will work. I can also see that if I create an instance of that class, so SB, an instance of Stefan Bolt, it also works, right? So similarly to the static method, this decorator allows me to create instances of this class that work both directly called from the class or directly called from the instance. Okay, so the only step up now is that in the static method, I don't have access to any class variables or anything other than the arguments that are passed directly to the method. In the class method, I have access to every argument that's passed directly to the method and anything that's inside the class dictionary. Okay, so then there's one logical step up from this. Okay, so here's just another example, sorry, is that you can also interact class methods and static methods, right? So given that all the static methods and class methods are defined in the class dictionary, that means that any class method can also see any other class method or static method. So you can start to make a hierarchical implementation of your functions. So for example, let's say we have a class that does some Newtonian mechanics. I want to be able to calculate the force given the mass, displacement, and time of some object, right? Well, force depends on acceleration, and acceleration depends on velocity. So I can have a static method that calculates velocity on its own that only depends on displacement and time. I can then have a class method acceleration that depends on this static method velocity and adds on an extra dimension to that. And then I can have another class method force that depends on this class method acceleration and uses the new argument mass, and then simply passes these arguments along through the chain, right? So then at the end, I can calculate my force. So now you start to see how, you know, essentially encapsulating your information into a class can actually be really beneficial, right? So we can start to make fairly complex behavior from very simple functions, right? Rather than having a function with 50 lines that does a lot of different things, I could have 3 small functions that depend on each other hierarchically, and that I only need to call one of to get the functionality I need in the simplest possible way. Okay. So, okay, we talked about static methods. We talked about class methods, and now there's one last thing, is to talk about instance methods. So now instance method isn't really a technical name, but it's just kind of the logical, let's say, step to connect the different types of methods we're dealing with. So an instance method is so basically, rather than assigning the method to interact with class properties, we want to assign the method to interact with instance properties. Okay, so here's a simple class. We're going to initialize our class with some argument that we pass so that it can access this value, and we're passing the argument self by default, right? So then when we define a new method, double, we have to pass self, because remember, if we don't pass self, it will raise an argument, and we don't want this to be a static or class method, so we need to pass self. Then we can tell this method to return the self.value, because I can access all of my instance variables, so anything with self can now be accessed, and I can double that or triple it. And what that means is that if I take 2 instances of this class, a simple class, I can initialize each of them differently and get all of the functionality like particularly suited to that instance that I want to deal with. So you can imagine, let's say you create a class that handles galaxy properties. So you have a bunch of functions that calculate the luminosity, the magnitudes, or whatever you want for your galaxy, and you have a whole chain of those. And all you need to pass in are certain variables like the apparent magnitudes of your galaxy or something like this. So what you could do is you could instantiate your class with the parameters for that specific galaxy and get all of those, let's say, calculated properties automatically for that instance. And therefore, each instance would be specific to the object you're dealing with. Is that more or less clear? Okay. Yes, instant. Okay, so the yeah, so yes, so keep in mind that the instances have access to everything that's in the class dictionary and their own dictionary. So, and basically, given that all of static and class methods and everything else are defined inside the class dictionary, instance methods can access everything, right? But if you redefine, so let's say if you have sigma as one of your class methods, and then you redefine an instance method sigma, it's going to override the class method, right? So basically you're going to default to the instance method, even though you could still access the class method. The default lookup will always be the instance dictionary and not the class dictionary.
And here in this example,
yep.
When you write the self.value equals 5,
yep.
the left value is an attribute that I am
yes.
creating.
Exactly.
And the right value
is the argument. Exactly. So basically, in this case, the argument value is being assigned to the attribute self.value. And then this function is calling the attribute self.value and multiplying it by 2, and this one is calling it and multiplying it by 3. So essentially, in this case, simple class 3 goes into here, which goes here, which gets assigned to this, which then gets multiplied by 2 and multiplied by 3. And then you can see. Okay. All right, so we're just going to spend a couple more seconds talking about methods. This is a kind of long, messy example, but it's just to kind of highlight that you can combine all the different types of methods you want in a class, and it's really down to you to figure out what type of method is appropriate for what you're dealing with, right? So here I have a class called list handler, and what I'm going to do is pass a list, and I want to get certain properties of that list. In particular, I want to get the length of the list, and I want to know what the first element of the list is and the last element of the list is, right? So what I have here are my instance methods, let's say, which are completely dependent on the list that I pass, right? Then I'm going to define some class methods that essentially take any list that gets passed to it and provide a given element. And then I have some static element methods that are providing functionality. So you can see that all of these things get added to the dictionary as expected. And then if I want to use it, so let's say, okay, I create an instance of my list handler. I'm going to pass it a list of elements 0 to 9. So then I now have 3 new attributes which are automatically defined in the instantiation of this object, which are the length, first and last element, right? So basically just by creating this object, since these attributes are defined, you can see here, self.length, self.first, self.last. So basically when this method gets called, it defines an instance attribute, and this element gets called, this method gets called in the init method. So that means that as soon as the class is instantiated, these attributes exist. Clear? Okay, so I mean the main point of that example is really just to show that you can have lots of different combinations of static class methods and instance methods, and they can all interact with each other in the right order, right? So that obviously static methods can't interact with anything, class methods can interact with static methods and other class methods, and instance methods can interact with everything. So in general, as a general rule of thumb, 99.9% of the time, you're just going to be creating instance methods when you write a class. But it is good to know what a static method is and what a class method is if you see it in somebody else's code, or you find a particular case in which you want to have direct access to those methods from the class, which is rare, but it's still possible. Okay? Yep. Yeah, yeah, right. So, so the underscore here is just a convention that says this is hidden. Yeah. Right. So basically, because there's no true hidden things, because everything can be accessed always in Python, this is just to say, like, to the user, you're not supposed to use this function, right? So if you have created an instance of this class and you're using the instance of this class, you should only be using things that don't have the underscore to use the correct functionality. The underscore things is like, if I have an intermediate calculation to do inside my class to produce the value you need, I can put an underscore because that's just like behind the curtain machinery operating to produce the output, right? But it's just a convention, right? In principle, it would work exactly the same if you didn't put the underscore there. But it's a good practice. Just this is what we talk about abstraction when we talked at the beginning of this thing is, the difference between what you want the user to know and what you want to kind of keep behind the curtain. Yeah.
Python tools, when they see underscore the front of the name, they say, oh, no,
yeah.
I don't care.
When double underscore is just for the stuff.
Well, the double underscore is like the same thing but extra, and it's basically like more to do. This is core Python, right? So essentially, like, you shouldn't be putting double underscores on your own things as a convention because it could really confuse a lot of people. Because if somebody sees a double underscore, they're thinking, okay, core Python developers wrote this as part of the machinery of Python. Single underscore, you as a developer wrote this as some hidden thing. No underscore, this is for the user to interact with.
Tomorrow I will put a presentation about this called double underscore. And that's someone called them magic Python. It's very, it's not forbidden. You just don't have to use the same name for function. but you can use it, no problem. But it's a very strong convention. Level underscore for the Python.
Yeah. So just in general, don't put double underscores for anything you're defining, unless it's like an init method for the class or something, which is a bit of an exception. Okay. So now that we've talked about methods, there's another type of attributes we can have in a class, which are properties. So properties, so basically a class property in principle are just like any values that you assign to your class. So if you have self.myAttribute equals 1, that is a property of your class. Okay, so the way that Python works is that you know, you can assign and mute any of these attributes whenever you want, but that doesn't mean you should, right? So in order to like enforce a bit of control on how you interact with these properties, you can start actually defining what are called getters and setters. So basically functions that set the value of your property, and then functions that retrieve the value of your property. So let's look at a simple example. So we have a class, again, a dummy class called myClass. We have an init method where we set a dummy attribute, and we set it equal to none at the beginning. So it has no value to start with. Then we have a get method where we return this value. So essentially, whatever that value happens to be at the time, this will simply return that value. And a set method where we pass an argument that assigns a value to this attribute. Okay, so if I create an instance of this class, then I can say, okay, get me the attribute, then I can set a value for the attribute and get it again. So as you can see, the first call, it has none because we haven't used the set method yet. And then in the second case, we get 5. Right, so now you might be asking, well, what's the point of doing that when I could have done that much more easily just by using an assignment, right? Well, why would I bother calling these functions where I could have just called the attribute and set the value of 5 directly? So the reason why you might want to define a getter and setter is maybe you want to control what kind of properties these properties have, right? So imagine I want to set only an integer. So if you try to set it as something else, I'm going to raise an exception. And when I return it, I want it to be a float because I'm, you know, being quirky for whatever reason. Okay, so here, so then basically what I do is my get method is going to return float of my attribute, and my set method is going to include an exception, right? So that if my input value is not an integer, or my input value is less than 1, I'm going to raise a value error that tells you that my attribute isn't the right thing. And then if everything's fine, I will set the value to my attribute, right? So simple, basically the same as before, except in this case, we have a type change, and here we have an exception. Okay, so you can see it works, right? So if we get the default value is 1, so an integer 1, and we get a 1.0. If we set an integer value of 5, we get a 5. And similarly, if we try to set an attribute value of -4, which is negative, and we said that wasn't allowed, it will raise an error. Or if we try to set the floating point value, when we told it it's only allowed to accept integers, it will also raise an error. Okay, so now you see, okay, now we're starting to exercise a bit more control over the property, you know, what these properties can be. But there's still nothing stopping the user from just doing the manual setting assignment of that particular value. So what can we do? So instead of initializing the attribute itself, we can initialize a hidden version of the attribute. So basically, we're going to have an underscore my attribute equals to 1. And our getter is going to return the hidden attribute, and the setter is going to set the hidden attribute. And then what we're going to do is use this special property function, which we're going to pass the get and setter functions to define the actual user value of my attribute. Okay, so this works the same as before, but the thing is now that the user doesn't have direct access to change my attribute. If they try to set this automatically with the wrong value, it will raise an error, because basically doing the dot assignment to this will call these methods. Now there's a more Pythonic way of writing this particular example, which is like this. And it's exactly the same thing, and it has exactly the same behavior, is we have this special property decorator, which is telling me that this function, which is the name of my property, is a property. So basically we have here the hidden version, here the user, like, you know, unhidden version, and it's a function, but I'm telling you it's a property. And basically what I'm doing here is defining the get method, all right? Then I can define a set method for the same attribute. So with my attribute name dot setter, a new function with the same name, the same setter performance as before with the same exception and setting the value to the hidden version. But we get the exact same performance. And I can even demonstrate that it fails if you try to manually assign a value to this. So now I'm going to say, my instance, my attribute, set it to value 5.6. It says no. This is not allowed, right? So now I have actually stopped the user from being able to break the code, right? Because now the things before, the user could have just said, my attribute dot this equals to whatever I wanted to, and you can't stop me. So now I can stop the user. I say, no, sorry, if you set this to the wrong value, you break the code. Now, of course, there's nothing to stop the user from accessing the underscore, but as if any good Python user should know, I shouldn't be accessing the hidden variables unless I'm told to. Yeah.
The name of the get attribute.
No. Exactly. It's just the order that matters. Yeah. So in the second example, the name does matter because it's the name of your actual property. In the first example, you could call the function whatever you want. Like, this is my getter function, this is my setter function. And as long as you put them into that property function in the right order, it will work. Exactly. So the point really is that you shouldn't really need to use that property function because these decorators are much better and more user-friendly, right? So this is, like I said, is the more Pythonic way of doing the exact same thing, but it's good to know what it's actually doing. Okay. Yep. Yeah. Mm-hmm. Oh, sure, of course.
Maybe in case we have things. I mean, if I define myself, my attribute
I would assume so, but I would have to test it to give you an explicit answer for that. So, I mean, the thing is that this is not just for types, right? The important thing is that you could say, all right, imagine your property is right ascension, right? So you say, I accept values that are floating point numbers from 0 to 360. If you give me -50, it's wrong, I raise an exception, right? And that way you can really constrain in many different ways what the parameters of this thing are. You know, say anything, you know, a declination below -90 doesn't make any sense, so I raise an error and tell you that you've put in a value that doesn't make sense, right? So you have basically what this just allows you to really customize what the properties are and how they behave beyond just the type. Okay, I think maybe we can stop there for a coffee break. Yeah. This one?
Yeah. So when I'm creating the instance, I'm calling the attribute my instance to my action.
Yeah, here.
Which order is it calling the methods inside the class? So first, we will be calling the instantiation.
Okay, so okay, so basically, when you create the instance, you're calling the init, right? So basically, this line here is calling this method here, okay? And in this method, it's setting the hidden version, so it's not doing anything with these at all. In this line here, you're calling the setter method because you're doing an assignment. So you're setting a value. If I just called my inst.my attribute, I would be calling the getter method, right? So basically, this comes right back to what we were talking about in dictionaries, right? So essentially, if you have a dictionary, square brackets key, you're doing lookup. Dictionary square brackets key equals something, you're doing assignment, right? So exactly the same thing with the class. This is calling the get method. This is calling the set method. Any other questions? Okay. I think maybe we should take the coffee break before going on to the next topic, just because it's a good natural stopping place. I think we have 30 minutes. So let's meet back at 5 minutes to 4, just so we don't lose any time. Okay, let's finish off this notebook. And so we're going to move on to a topic called operator overloading, which sounds really fancy, but it's not that much. Okay, so we talked about earlier that we had these double underscore methods in Python that are kind of, let's say, hidden methods. Right, so one of the ones that you're going to interact with extremely often when you're writing classes is the init method, right? So obviously, if you want to be able to instantiate class objects, then you want to be able to define what the instantiation procedure should be. But there are actually other these dunder methods inside the classes that you can overload. Basically means replace the default behavior with to add some customization to your class. So I'm just going to show you a couple of examples of these things. I would say these are things that you don't need to use very often, but it could be useful in certain circumstances. It's good to be aware of them. Okay, so let's start as usual by defining our typical dummy class with nothing in it. Okay, so notice that if I just print an instance of my class, it doesn't really give me much information, right? I know that it's an instance of my class and it's an object, and it's not very user-friendly information. So in fact, I can override this default behavior and change that. So let's say I define a class called wolf. I set up the instantiation that I want for this. So I want to be able to pass an argument called age and name and set those instance properties. Now I'm going to define a new method called string, so underscore, underscore, string, underscore, underscore, which is going to overload the default class behavior for this string, right? So the default behavior we saw is when we just printed an instance of that string, right? And I'm going to tell it to print out some more like user-friendly information. So it's going to tell me what's actually stored inside this instance. Okay, so if I create two instances, so I create one with inputs 3 and this, and second with 2 and this. Now, if I print the instances, you can see that I get a lot more user-friendly information that I've defined. So I can customize this to print out whatever I want it to be. So if you had a class that does something, and so you have a user who's creating instances of your class, and you want them to get a bit more verbose out of that, so they could basically print the instance and say, oh, okay, this is a galaxy with such and such properties. This isn't the instance I was looking for, it was this other instance or something like that, rather than it just printing out something like, instance of such and such class. Okay, so all I need to do this is this special str method, right? So again, keep in mind that you're overloading the default behavior. So there's already a default str method. And by doing this, you're telling Python to use your method instead, which is going to change that default behavior, right? So this is really like purely for customization's sake. There's another method that's fairly similar, which is instead of the class string, it's the class representation, right? So this does a fairly similar thing. So we can, put in some custom verbose in this. We can create instances of our class, and instead of printing the instance directly, we can print the representation of that instance. Now the difference being is that when you print the string, it's more kind of generic user-friendly sort of thing, and the representation is more for like developers, right? So you would think in mind that if I want the user to print this, I want them to see something that is kind of clear as what's going on. And for the developer, I wanted them to okay, I want to give you something that's a bit more structured so that you know what you're dealing with for modifying this code. So the other thing to keep in mind is that the representation is what's called, if you simply in an interactive Python session, instead of writing print and your object, you actually just run the object you get an output in an interactive Python like Jupyter, and that output by default is the representation. So if you ever, running a Jupyter notebook and you see some output and you haven't written print explicitly, what you're getting is the representation for the object you're dealing with. And that will be whatever the default is, unless you predefine an overloading customized representation for that particular object. Okay, so again, not something you're probably going to do on a day-to-day basis, but it's good to know that you can. Okay, so now a bit more practically, like there are other methods that you can overload in Python classes, in particular mathematical operators. So imagine we have a class called building, in which we initiate with a name, year, and height. Then we have an overloaded add method, an overload multiply method, an overloaded less than method, and an overloaded greater than method. So what I'm doing here is telling Python what the default behavior should be for addition. So essentially, if I have 2 instances of this class, and I say add these 2 instances, Python doesn't know what to do with that because these instances are not mathematical objects, right? So what I can do is define what the add method should be and tell it, say, okay, when I add 2 instances, what I want you to do is take the height property from both instances and add those together. And, and similarly for these other properties, right? So we can have a look at an example of this. So we can have 2 instances, one for the Burj Khalifa and one for the Empire State Building. And then if I basically look at the height property from each of these, then I can see that if I add just the instances themselves, not the heights, the instances, I get the sum of the heights, and so on with the multiplication, less than and greater than. So you can really customize how instances interact with each other. So now it starts to become pretty interesting because you could start thinking about, again, like if you have galaxy properties or star properties, you say, okay, I have a galaxy and I structured it in a class such that I can keep all of these things. Maybe I want to be able to add all the magnitudes together if I add 2 instances of the class galaxy. So then I can define that behavior such that that is the case. So then I can get this really complicated way of all of these instances to interact with each other. Nothing. Yeah, because it will raise an error because there's no mathematical object to add.
So it doesn't by default
No, because some of them might not be numerical values or strings, But
there is the default output.
Well, it's yeah. Yeah, well, yes, but it probably doesn't do anything. I don't know what it does by default, but you'd have to look inside. But okay, okay. So then there's a call method. So what does a call method do? So this one, again, I can't think of a lot of practical applications where you'll be using this in your daily life, but it's kind of a cool thing to know about. So the call method allows your instance to behave like a function. So that essentially you can pass an argument to the instance. So basically, imagine we have this greeting example. We instantiate greet with an argument, which is the type of greeting we want to give. We store that in a property. Then we define a call method. And the call method has its own argument. And what it's going to do is use the class instance greet method with the argument that's passed to this call method, right? So have a look at an example. We're going to instantiate this greeting with the greeting howdy, right? So that's instantiated. And then we can call the instance with an argument Arnold or Sylvester, and you see. Right, so basically that allows basically kind of like a instantiated function, if you want to think about it this way. So imagine you have a function that you want to set up some properties for. Let's say you have some cosmological parameters you want to preset. So you could say, okay, instantiate omega matter is equal to this and such and such. And then I have a call method that calculates the Hubble parameter or something. Okay, so that you could then put in some argument to that instance, and it would work like exactly like a normal function, but it would have these instantiated properties that it can interact with. Right. So again, not something you're probably going to use very often, but it's again pretty useful to know about, especially if you see somebody else's code written in that way. Any questions on this? Okay. Okay. So I didn't have the time to include a completely exhaustive list of all the things that you can overload in Python classes. I would say in general, you're not going to do a lot of overloading on your day-to-day life, but it would be, it's useful to know that this is a thing you can do and that you can look into if you want to, right? So if you want, you can go look up a list of all the overloading methods that are available and figure out what things that you can customize in the way you want it to do. So here's just a list of a couple extra things that can be done. So you can check the length of your instance. You could check to see if your instance contains something. You can also do an indexing of your instance. So let's have a look at an example. So here's a class called birth dates. We instantiate without any arguments and create 2 empty lists. Then we have an add method that we provide arguments to, which appends values to these lists. Okay. Then we're going to have a length method that looks up the length of the names list. We're going to check to see if an argument exists inside the names list. And then we can do an indexing of both the names and years. Okay, so let me show you that in practice. So create an instance of birth dates. Then we're going to add 3 famous scientists and their corresponding birth dates. And we can check, okay, if we do length of the instance, we get 3 elements. We can check to see, is Isaac Newton in the instance? It's true, he is. And we can index the first, the second element of the instance is Marie Curie. So we can actually customize the behavior of how the outputs from these instances will behave. So again, you can really think of almost limitless possibilities of what you could do with these operator overloading methods. Okay, any questions on this? So it was really more just to kind of highlight that it's possible. I don't really have many practical applications where you're going to need to use it in normal projects, but it's worth knowing about. Okay, I think so. Starting off with just doing something simple. This is really to get back to the idea of encapsulation. Like, so how can I use a class to combine methods that have similar properties together into a single object that's useful for me?